Thank you very much, everyone, for joining us. Just a few seconds to allow people to join. Okay. Well, thank you very much, everyone, for joining us. This is the last VSET seminar for the year. We will probably start when the job market winds down. So we'll start again sometime late February, early March next year. Today we have Roberto Corrao, who's talking about mediation markets, the case of soft information. We also have Xiao and Roland Strausz as panelists, which we thank. And I just want to take a second to announce that we are going to have a face-to-face workshop. It's in honor of Miltos Makris. We organize this every year. We were doing this before COVID, and this is going to be April 3 and 4 in Madrid. We almost have a completed lineup. It's not quite complete, so we will put this information on our webpage as soon as we have a complete lineup. But just in case you might be interested in attending, it's April 3 and 4 next year in Madrid. Having said all of that, Roberto, please, the screen is yours.
Okay. First of all, let me thank you so much to the organizers for inviting me. I'm very happy. And of course, let me thank the panelists for accepting to be here and say something about the paper. So today I'm going to talk about mediation markets, the case of soft information. And let me actually start immediately with some brief motivation and a general setting. So I don't need actually to motivate that much with this crowd, with this theory crowd. The main setting of my analysis, which are markets with information asymmetries. Indeed, information asymmetries are pervasive in especially financial markets, but basically any kind of markets. Just think about the case of a seller who is superior information about an asset or a service quality that they want to sell to buyers, which are less informed. However, the buyers in turn have the power to take an action, in this case, whether to buy or not, that is payoff relevant for all the agents. These situations are pervasive, and in real life, we see the presence of third parties, which I'm going to call as information intermediaries. And to make things concrete, you can think to credit rating agencies in a financial market, whose role is to transmit information from the seller, from the informed party to the uninformed party in exchange for money, in exchange for remuneration. And in particular, I want to stress that in most of these markets, and especially in the credit rating agency market, the model followed to get payments is the so-called issuer pay model, in which is the privately informed party that has to pay the rating agency. However, this is a subject of controversy. Why? Well, because most of the time, and again, especially in the case of credit rating agencies, these mediators, these intermediaries act in a monopolistic regime. So the natural question is whether or not having monopolistic regime as opposed to a perfectly competitive regime among these information intermediaries is welfare enhancing from the point of view of the receivers. So from the point of view of the customers, the institutional investors that are going to use this information to take their decision. And that's the main question I'm going to address in today's talk. I want to stress that, of course, while this question has been already considered in the literature, of course, given its relevance, I'm going to propose a model that has two main novelties that I think are very relevant in order to address this question. The first one, as the title suggested, is that I'm going to focus on the case of pure soft information. This means, what I really mean by this term is that the private information held by the sender, by the informed party, is not verifiable. Not even the intermediary can verify this information. So, for example, you can think about the exact composition of a mortgage-backed security in the case of an issuer, or the exact remuneration of an asset. The information is held by the privately informed sender, but this cannot be verified. However, the mediator has some commitment power, as you will see formally in a second, to commit to a communication mechanism. The second novelty with respect to the usual literature is to consider a mechanism design approach in which the mediator is, or the mediators are free to select any kind of contract, in particular, any kind of mechanism in order to extract surplus from the center. let me be a little bit more concrete on why these assumptions are relevant and why soft information, non-verifiable information, is important in these settings. And in particular, I want to stress this quote that I took from the Code of Professional Conduct issued by Moody's almost 1 year ago, in which Moody's describes themselves not as an auditor that can verify independently the information received, but just as a third party that can transmit information that has to be reported willingly by the issuer to the rating agency. So even the rating agency themselves do not describe them as certifier that can always verify this information. So I want to stress that the presence of soft information not only is important and realistic in this market, but at the same time has been a little bit overlooked in the literature, even if I have to say something about the literature regarding this assumption. Of course, the rating agency and the issuer market is not the only case of soft information. We have also examples of misreporting for residential mortgages and securitized loans, and the crisis, the 2008 crisis, showed us how misreporting and the impossibility to verify information could have disastrous consequences. But this presence of soft information goes well beyond financial markets, and we have empirical evidence even in the development settings or even in ranking for universities in which there are some famous scandals of universities misreporting information regarding to the agency that were ranking all these problems. So again,
Roberto, can I ask you a question?
Yeah.
Because of the quote, you stress very much the soft information. But if I read the quote, it says that it can verify, that Moody can verify and validate information, which is a little bit more to me than soft information. It's more like verifiable information that, of course, has to be given voluntarily. But it sounds a little bit more than just soft. Or am I mistaken here?
The way that I'm interpreting this is that whatever information they take, they cannot, okay, there is for sure some part of the information that is payoff relevant that they cannot verify. So to me, the way that I translate this is that the message, the report, at least in part, is pure cheap talk from the sender, so the issuer, to the rating agency. Then the rating agency has enough reputation and commitment to credibly commit to a mechanism that is going to take these reports and transmit some of them to the markets. But again, they don't have always the means in order to verify whether these reports are truthful or not. Hence, the presence of soft, or if you prefer, non-verifiable information. Okay?
Okay, thanks.
Perfect. This is the motivation. Of course, again, there is a huge literature on optimal certification. Roland himself and Xiao have nice contributions on this topic. However, as I was saying previously, the main case that has been analyzed so far is the one of hard information. In this paper, I'm going to focus on the opposite case of soft information. To give you a brief picture of what the model is going to be, again, let me tell you the story of and apply my model to the case of to financial markets with credit rating agency. So I'm going to consider an agent, the sender, that you can think as a bank, that is privately informed about a payoff relevant state, for example, the composition of a mortgage-based security asset. Then there are, on the other side, investors, which is a market that is uninformed about the payoff relevant state of the world, but they can take a payoff relevant decision, for example, whether to invest or not in this asset. And then we have a third party through which communication happens. Now, this third party, which I'm going to call the mediator, for example, can be interpreted as a credit rating agency, like the receivers, is uninformed about the state of the world and cannot verify the state of the world. Like the sender, cannot directly take the action. So it's not a case of standard allocation mechanism design in which the designer can directly choose the final allocation. But the mediator, differently from these other two parties, has some commitment power. So they can commit to take some reports from the sender, which again cannot be verified, send these reports, maybe garbling them in the form of ratings, to the investors, which in equilibrium are going to update their beliefs about the state of the world and take the optimal actions, and also to commit to some fees. So these fees are going to be nothing but the final remuneration of the mediator given this service that is given to the sender. So this is, in an abstract sense and not very formal sense, the model. We're going to see it more formally in a second, but let me try to tell you what I'm going to actually do. I'm going to analyze this model by combining mechanism design and information design. Indeed, as you might have already seen, I'm going to treat the mediator as a standard mechanism designer that faces at the same time truth-telling constraints with respect to the sender and the reporting problem of the sender, and obedience constraint with respect to the population of receiver. I'm going to assume a standard single crossing condition on the payoff of the sender, which in this interaction plays the role of the agent. And I'm going to show that the presence of pure soft information plus the possibility that the fees, the prices that you have seen here can depend on the report, implies that fee in any equilibrium fees, so the remuneration for the mediator, must be positively correlated not only with the fundamentals, but also with the equilibrium ratings that are disclosed to the market. This is a key prediction that differentiates this case of soft information, in which we must have this positive correlation and this assortativeness in equilibrium, for the case of hard information, in which the covariance and the correlation between fees, ratings, and fundamentals must not, it's not in principle restricted by the equilibrium condition. This is a condition.
Can I ask a question?
Yes.
Sorry to interrupt. I'm kind of still unsure of exactly what you have in mind. So this is a mechanism where I commit, I provide incentives to the sender to send me information through perhaps reports that I commit to do. But does the receiver see the contract that I have with the sender, for example? Or is this something that would emerge in equilibrium or any other assumption? So you see what I mean? I'm not entirely sure who the contract is with and what you're committing to.
The contract, the menu, if you want, the menu of contracts is chosen by the mediator, and this could be observed by everyone, especially by the receiver. What is selected in the contract is not observed by the receivers; is only observed by the mediator, but the mediator has committed to, for every report, so for every selection from this menu, if you prefer a less direct mechanism design approach, is going to see the realization of the potentially stochastic message that is going to be extracted according to the distribution given the report. So what the receiver observes is the menu of contracts from which the sender could choose, and the final message that the choice of the sender and the mechanism are going to extract. Does this address your question?
Yes. Thank you.
So, for example, I'm not going to assume that the transfers can be observed. The realized transfers will not be observed.
Sorry, Roberto, sorry to jump in. Relatedly, so should I interpret the model as, say, there's a credit rating agency who design a rating policy that map from fundamentals to certain ratings, and this is something public on their website, it's online, it's easier to monitor, or it's easy to contract on, right? If I deviate from that, you can sue me on the court. This kind of justify the commitment assumption of the intermediary. But on the other hand, the issuers can manipulate or falsify the document submitted to the credit rating agency, and that's why the information is soft, and that's where comes the incentive problem. So should I interpret the model in this way?
Yes, and while it is important that the rating agency have enough reputation to commit to this communication mechanism, again, if you look at the quote, that's why I wanted to show you the quote, they kind of are immune to the potential problem of verifying, of the necessity to verify the information, because they claim themselves that they're going to take often the reports from the issuer as given, and what they're going to do is to manipulate this report, being truthful or not, and send a potentially garbled message to the market. Okay. So remember the question. The question was more whether or not the receiver, so the market is better off in a regime of pure monopolistic regime, in which, of course, I'm going to treat this mechanism design problem as a nonlinear monopolistic pricing problem, or whether the receivers are better off in the case in which the mechanism and the equilibrium are selected so to maximize the payoff of the sender, which, remember, in this interaction, in the interaction between the sender and the mediator, play the role of the buyers of this bilateral interaction. And the answer, the perhaps surprising answer, is that actually more often than not, and under regularity conditions, the monopolistic solution is going to provide more information and in general to give more average utility to the receivers than the perfectly competitive case. And there are two main reasons behind this result. The first one is the usual distortion that comes exactly from having disincentive problems. Indeed, the monopolist is not going to try to maximize directly the surplus of the sender, but a distorted version of that surplus, the so-called virtual surplus, that has to take in account the information rents that the mediator has to give to the sender in order to satisfy truth telling. And in the regular case, in which the inverse Hazard rate is decreasing, these information rents are going to increase the supermodularity of the virtual surplus with respect to the original surplus of the sender. This means that the actual payoff that a mediator, as opposed to a sender with commitment, is going to maximize prefers more assortativeness between in the matching between states and final ratings. More assortativeness is closer to more information, and therefore the receiver is going to be better off. There is a second reason for why under monopolist the receiver can be better off, and the reason is that if we also impose that the transfers from the sender to the mediator cannot be negative, so we can only accept payments, then these transfers literally play the role of money burning in standard cheap talk models. And we know that the monopolistic mediator is basically selecting the communication mechanism that maximizes the amount of money burning in the economy. Why? Because this money burned is nothing but the final revenue of the mediator. At the same time, we know that more information is sustainable when the amount of money burning is higher in equilibrium, and therefore the money burning maximization of the monopolistic mediator is going incidentally also to maximize the amount of information in the equilibrium. But we're going to see all of this more formally. I just want to point out that this prediction that more information is actually present with monopolistic competition as opposed to more competitive markets is what we seem to observe in empirical data, in financial empirical data that, for example, analyze the case, these couple of papers that I'm showing here, analyze the case in which Fitch entered the market of rating agency, and they observed that the quality of ratings and the informativeness of ratings actually decreased after the entrance of Fitch in the market of the big four rating agencies. So let me actually almost skip the literature, except for one paper that I want to mention, not just because it's Roland's paper, but because I think it's relevant with respect to what I said, which is this recent nice paper by Celik and Strausz, because it's true what I've said, that most of the literature so far has focused on the case of hard information, but there is this recent paper in which both hard and soft information are considered. The analysis is a bit different and the setting is a bit different, and they do not compare monopolistic and competitive at the competitive case. But I want to stress that the literature is starting to move toward integrating more and more the case of soft information, or at least what I define as soft information as opposed to pure hard information. So having given to you this broad introduction, let me actually jump into the formalization of the model. Again, you will see the same picture that we have seen before, but now with some more math. I'm going to consider a sender who is privately informed about a payoff relevant state of the word theta, which is distributed according to common prior f with positive density little f. Then there is an entire population of receivers which are characterized by this type R, which is going to be uniformly distributed, and this is without loss of generality. And each receiver R is going to have a binary action, whether or not to invest in the asset that is issued by this bank. Of course, 1 means that they invest, 0 means that they do not invest. So what are the payoffs given these primitives? The receiver is going just to compare the conditional expectation about the state, the value of the asset, with R. So you can see already here that R is that their type is playing the role of their outside option if they decide not to invest. And of course, they're going to play 1 if and only if their conditional expectation about theta is greater or equal than their outside option R. What is the payoff of the sender? I'm going to normalize the payoff of the sender for each receiver R to 0 if they play the passive action 0, and to be a linear function of the state that positively depends on the state through 2 functions, alpha R and beta R. So in principle, I'm considering a general enough payoff for the sender that can depend on the outside option of the receiver in this linear fashion. I want to stress, though, that there is a positivity assumption with respect to this state-dependent and state-independent component. Now, what happens if
they are complementary, the R and theta? They are complementary.
Exactly, right? Exactly. Basically, what I'm really assuming is supermodularity, strict supermodularity between R and theta. And strict monotonicity with respect to the participation of all the receivers R. So what happens when we consider public chip talk? Again, I'm going to assume that the sender and also the mediator are going to communicate at the same time with all the receivers. I'm not considering private communication with this receiver. If we analyze this model with chip talk, we can see easily that only the bubbling equilibrium is going to survive. Why? Well, because the sender has a strict incentive to induce the highest possible conditional expectation for the state in order to maximize participation, and this is the only equilibrium that is consistent with this is the no disclosure one, because if there is some informative equilibrium, then the incentive compatibility constraint under chip talk is not going to be satisfied. So so in other words, we are saying that in these kind of markets, the presence of a mediator is necessary even to begin to think about information transmission from the sender to the receiver. So let me consider this third party, which is going to play the role of the mediator and is going to be just standard Myersonian mechanism design. What the mediator can do, as I was saying in the introduction, they can commit to a communication mechanism. A communication mechanism is composed by 2 message sets. The first message set is the set of reports that the sender can submit to the mediator. The second message set is the set of messages from which the message for the receiver is extracted.
So here I would have thought that what the mediator says the receivers is now a recommendation rather than a message.
Sure, and we are about to consider the reduced form in a second. Let me just state the general mechanism, the same problem, and then we're going to apply immediately a revelation principle. Then there is a message for the receivers, and this message is extracted according to a stochastic function sigma. This sigma takes a report MS from the receiver and gives you a distribution over messages takes a report from the sender and gives you a distribution over messages for the receivers. And finally, there is a transfer function. This transfer function takes the report of the sender and gives the price that has to be paid by the sender to the mediator. And this price corresponds to the payoff of the mediator himself. What happens to the payoff structure? Well, the payoff structure is exactly the same as before, with the difference that now the transfers are taking account both in the payoff of the sender and the payoff of the mediator. Importantly, I'm not considering transfers for the receivers. The receivers play somehow passive role in which they're going to observe this information, update their beliefs, and then take their action.
Now, and does it matter that the mediator cannot collect information from the receiver?
Very good, very good. In most of the cases that I'm going to show, in particular in this linear case with uniform distribution, I'm going to show this is without loss of generality. And actually, the proof it's almost the same as the proof in this nice paper by Anton Kolotlin and co-authors. It's an econometric note called Persuasion with a Privately Informed Receiver, in which they show that in these linear settings, actually committing to a single experiment is without loss of generality. You don't want to discriminate receivers. Now, the same result would hold even if you add a truth-telling constraint for the sender. Having said that, if I were to analyze more general settings with more general payoffs, then your concern would be important, and we should start to think about discriminating the information also for the receiver. In other words, screening also the receivers. An important assumption before going on, I'm going to follow the usual, the literary mechanism design by allowing the mediator to select not only the mechanism, but also the equilibrium given the mechanism. And this in particular implies that I can put a restriction on out-of-path beliefs. By out-of-path beliefs, I mean the beliefs that the receivers will have every time that they see that the sender did not enter in the contract with the mediator, did not accept the contract that the mediator proposed. In particular, I'm going to assume that every time that they see non-participation from any sender, then they're going to assume immediately that the type of the sender is the worst possible, equal to 0, and therefore their conditional expectation is going also to be equal to 0. Again, from the point of view of a monopolistic mediator, this is the best selection of out-of-path beliefs, and indeed is often considered in both the literature of mechanism design with evidence and communication and optimal certification. So I'm going to assume this particular selection of out-of-path beliefs.
Roberto, just a clarifying question. There's only one R, so all the receivers have the same R, right?
No. R is uniformly distributed on 0, 1.
Okay,
There is an entire
Rs.
continuum of receivers.
Okay, thank you. Thanks.
But they observe the same little m R, the same realization of the information communicated by the mediator. But of course, they're going to take different actions. Why? Because each of them is characterized by a different outside option. Okay?
Roberto, can we just go back to my previous question again, just to make sure this is correct? As a receiver, I know that the contract consists in an MS, and I know what that is, an MR, and I know what that is. So this is common knowledge, what MS is, MR is,
perfect,
sigma is, but and that there is going to be T, but I don't, do I know, is it common knowledge? No.
You know the function. You know the function. You
do know the function.
What is MS, little ms. You only will see little mr. So you will see the realization of the message.
But I do see, so I mean, this is an important assumption that the receivers know what the T function is. That's important because so presumably I make this point because presumably in reality they well, depends on which kind of investors they are, but some of them won't really understand.
I actually was thinking to put the fees, but I could actually download the fees that Fitch, Moody's, and Standard & Poor's have in their
okay. All right. So these are somewhat sophisticated. Right. Okay. So these are okay. Okay. Investors are sufficiently sophisticated to do
understand.
That.
Yeah. Again, the fee schedule. Sorry, I should have said the fee schedule. This is different from observing what a certain bank exactly paid to Standard & Poor's.
Oh yeah. That's fine. That's
very important, of course, as an assumption.
Just in terms of if we're going to take the Moody's example seriously, is their transfer, is they doing uniform pricing, or their transfer actually, the pricing actually depends on your fundamentals?
Good. Again, that's the important thing. These transfers do not depend on the fundamental. They depend on the report that is selected by. So again, of course, in practice, you don't see sender reporting something and receiving a transfer that they have to pay in exchange. They select from a menu, though. So I could reorganize. I could.
So you're saying they're indeed offering
for this mechanism design in which each type of the sender is going to select from a menu. That self-selection, of course, in a setting in which the set of the class of menus is not restricted, would replicate this idea that the transfers depends on the report sent by the sender. Again, it's not it's not that the transfer depends on the fundamental. Okay?
So it's just, what does the menu look like?
For example, in this case with soft information would be a menu of experiments that though are not informative at all with respect to theta. Again, because you cannot verify theta. So suppose that I'm the mediator and I propose to you a set of pure noise of experiments. You're going to select one experiment from this menu. The receiver, knowing the menu and being a rational agent, observing the message from this pure noise experiment, is going to infer something about your type. And the inference is going to be just the inference that he knows in equilibrium what type theta is going to select from the menu.
So I don't think, but I don't want to hold you here. So we probably can discuss
okay,
later.
Okay, let's discuss maybe later. But it's the standard, it's what a mechanism designer would learn from about an agent when they only observe what they have selected from the menu. Okay? Good. As I was saying, all the actions of all the receiver only depend on the conditional expectation, that the public conditional expectation that the receivers will form. Let me denote this with little x. Every receiver is going to take the active action A equal to 1 if and only if this conditional expectation is greater or equal than R. This allows us to write the sender's payoff indirectly as a function of the public conditional expectation X and their actual state of the world by integrating over all the receivers that actually take action 1, which are all those receivers whose outside option is smaller than R. And this allows me to define the payoff of the sender as a function of theta and the conditional expectation X as this linear and strictly increasing function of X. Now, how can we represent a mechanism? Well, we can represent a mechanism in terms of the outcomes that they induce. And an outcome is, on the one hand, a joint distribution over states and conditional expectations that arise in equilibrium. So a mechanism and an equilibrium induce an outcome. The second part of the outcome is a transfer function, which is going to establish what every type of the sender is going to pay in this mechanism and according to the equilibrium selected. And all the payoffs of the receiver can be expressed solely in terms of this outcome function pi and the transfer function t. And I'm going to say that a pair pi t is implementable if there exists a mechanism and an equilibrium described as in the previous slide, such that they induce this outcome and this transfer function. Okay, what are the programs that I'm going to analyze? As I was saying, I want to consider at least 2 programs, but actually I'm going to consider a third program here, and you will see in a second why. The first mechanism design problem that I want to analyze is the classic one, in which the mechanism and the equilibrium are selected so to maximize transfer. So this is going to be interpreted as monopolistic mediation. And here we select both pi and t among the implementable ones so to maximize the expectation of t. On the other side, we have a completely different mechanism design problem in which we select the implementable outcome so to maximize the ex-ante payoff of the sender. So we select pi to maximize v minus t under the constraint that on average all the mediators, which you can interpret as an infinite fringe of mediators, make at least weakly positive profits. And that's why this would weakly induce these mediators to stay in the market. However, I want to stress that according to this program that I interpret as perfect competition, we still allow the transfers to be negative. So in this program, while the expected transfers are going to be weakly positive, it is possible that in some state of the world, some type of the sender is actually paid by the mediator. And that's why I want to actually also consider a more restrictive case in which I still maximize the ex-ante payoff of the sender, but I impose a stricter constraint on the mechanism, and this constraint is such that the transfers from the sender to the mediator is weakly positive no matter what the state, not just in expectation. And both of these can be microfounded with Bertrand competition, again, among an infinite fringe of mediators. So again, these are the three programs that I want to analyze. Monopolistic mediation, then sender preferred outcome with a more lenient restriction that says that profits are weakly positive in expectation, and then a restricted sender preferred outcome in which all, regarding the type, all the transfers, regardless of the type, all the transfers need to be weakly positive. I claim that the right comparison is between monopolistic mediator and restricted sender's preferred outcome. However, it is also instructive and useful to carry this intermediate case, because this case often is going to collapse to the standard Bayesian persuasion case. And therefore, by comparing monopolistic mediation and this intermediate case, you also have comparison between a case in which the sender could commit to begin with to an information structure and the present monopolistic mediation case. So let me stop 1 second here to be sure that what is implementable and the three kind of programs that we have in mind are crystal clear to the audience. Perfect. Yes.
So, can you elaborate on how the competition among mediator correspond to the sender's preferred outcome?
So again, suppose that the mediators all of them are going to post a menu of a mechanism like the one that I introduced before. And suppose, importantly, that the sender is going to select what mediator, what contract to accept from the mediator before they learn the state. So there is an ex ante participation.
I see.
In this
so
case.
this is not like a credit shopping where I go to Modi first and then I look at my score. I'm not happy. I'm going to another credit.
No. This is not what I mean. It's not what I mean. It's a model in which it's a competitive screening model, if you want, with an ex ante participation constraint.
Thanks.
Perfect. Let me actually, given that I'm a little bit behind, let me avoid to talk about the example and go into the meat of the analysis. So let me first analyze implementable mechanism. Again, the setting is a standard setting as in Myers on 82, so we can apply the revelation principle. And the revelation principle tells us that we can focus on outcomes, so distributions over conditional expectations and states and transfer functions that satisfy only these four properties. The first property, consistency, just says that the common prior assumption is valid, meaning that if we take the marginal over states, we go back to the common prior f over theta. The second restriction is the truth-telling constraint, or if you want, the honesty constraint for the sender, that says that the sender is weakly incentivized to truthfully report the state, meaning that the expected payoff they get by truthfully reporting their state minus the transfer that they have to pay to the sender is weakly better than any conditional expected payoff that they can get with corresponding transfer by lying and misreporting their type. Then there is an obedience constraint, which again, this is related to Roland's question about an actual recommendation. In this direct implementation, you can interpret X, the outcome conditional expectation, as the recommended conditional expectation that all the receiver should hold after they observe the message. But of course, you must satisfy some consistency condition with respect to bias updating. In this case, the condition is the usual martingale constraint that says that when the mediator is going to recommend the market to hold a conditional expectation equal to X, that is indeed the conditional expectation that the rational receivers are going to have when they update correctly their beliefs. And then we have a final participation constraint that says that the expected payoff of all the types by participating to this mechanism is weakly better than the expected payoff that they get by non-participating, which, remember, under our assumption on out-of-path beliefs is just equal to 0. So again, standard obedience and truth-telling constraints, but here considered together in this joint distribution of outcomes of conditional expectations and states. Perfect. The first results that I promised to you is actually a restriction that any equilibrium must impose on the covariance, if you want, the correlation between theta and transfers and ratings. Before getting to that, I'm going just to show that pi, this joint distribution of conditional expectation and state, is implementable if and only if it satisfies consistency and obedience, and you replace the usual truth-telling constraint with a monotonicity constraint. What is this monotonicity constraint? This is saying that Eiger reports must be mapped with Eiger marginal utilities of the sender. Again, this is the standard monotonicity assumption that characterizes truth-telling, the truth-telling constraint in one-dimensional screening model. Here is stochastic exactly because we don't want to restrict immediately on deterministic mechanism, but still, given the linearity of the payoff with respect to the state, we can completely characterize implementability with respect to this monotonicity.
Roberto,
yes.
Maybe I'm missing something. Is there also an out of equilibrium event? So if the investors don't see the guy picking the mediator, then they also have to have a belief about theta.
Perfect.
Is that?
Yes, it's what I have assumed is exactly that these beliefs are going to be the most negatives possible.
Okay.
And again, this is consistent with the mediator selecting the equilibrium, and as part of the equilibrium, the mediator can also select
I missed that
the
one. Okay, thanks.
the out-of-path equilibrium. And this is why, by the way, we have this 0 here. The participation constraint is the outside option is equal to 0. Now, this monotonicity completely characterizes the truth-telling constraint. What this monotonicity is saying in stochastic terms is saying that according to every implementable pi, there must be positive correlation between the fundamental state and the marginal utility of the sender. However, given that this function is strictly monotone, it follows that there must be a positive correlation between ratings, which I'm going to interpret as the recommended conditional expectation to the market, and states. On top of that, by the standard envelope formula, we can show that the transfers that are going to sustain this pi in equilibrium are non-decreasing as a function of theta, which in turn implies that in any equilibrium, we must have positive correlation between the ratings, as represented by this marginal utility, and transfers. So some implication that the soft information assumption makes in this model is that in any equilibrium, even before optimizing, we must observe positive correlation between ratings, so conditional expectations, and the transfers that the sender pays to the mediator. So this is, if you want, a way to identify the presence of soft information. Why? Because with hard information, in principle, such positive covariance restriction should not be present in the joint distribution between ratings and transfers. So this is a necessary condition. This does not imply that, this does not restrict the set of implementable outcome to just monotone partitions. You can in principle have a random mechanism that match each state with multiple conditional expectation, as long as the monotonicity of this conditional expectation is satisfied. Now, I gave you good news in terms of implementability.
Sorry, can I jump in?
Yes.
Just trying to understand the implementation condition. So if it is deterministic, then it must be monotone partition, right?
Perfect.
And what if the V function is state independent? Then you can implement everything. Basically, there's no constraint at all. No, it's not no constraint. It's right. You can implement any stochastic outcome.
Yes, if given that you have transfers, if you have both transfers and transparent motives, then you can, I think, yes, you are going to extract for full surplus from the sender and solve the corresponding Bayesian persuasion problem that maximizes the ex-ante payoff of the sender and fully extract it. Again, this of course relies on the selection of out-of-path beliefs that I made, meaning that the mediator can also select in the best way possible the equilibrium out-of-path beliefs of the receiver.
So in terms of the off-path belief, do you have examples showing that without this selection, actually the intermediate cannot do as well? Or in fact, there might be some unraveling argument to show that as long as you design the test and fee structure carefully enough, you actually can ensure that that's the unique equilibrium.
I mean, yes, there is a similar argument in Litzeri
Yeah.
that does that.
You probably need some assumption on the prior.
Yes. However, Litzeri has what you just call a payoff, a state-independent payoff of the sender, because the payoff of the sender Litzeri is just the conditional expectation of the receivers. I don't know exactly what would carry through that result in this more general setting, but it is a good question. There might be a condition that would generate that endogenously. So I told you that all the equilibria must exhibit this positive correlation between ratings, so conditional expectations, and states and transfers. What about marginal distributions over ratings? So the question that I'm after here is the following. Is it possible to, by just looking at the marginal distribution over conditional expectation, is it possible to establish whether or not that marginal distribution was coming from a regime with soft information or was coming from a regime with no restriction on the experiments that can be chosen? Well, the intuitive answer would be yes, exactly because we have this monotonicity restriction, this coming from the truth-telling constraint. However, the bad news is that on top of the standard condition that comes from Blackwell, from the Blackwell result, that the marginal distributions over conditional expectation has to be a mean-preserving contraction of the prior. This turns out to be the only restriction that you need, even under the presence of monotonicity, in order to characterize all the marginal distribution over conditional expectation. In other words, the previous monotonicity condition has no bite when we only care about the marginal distribution over conditional expectations. And the reason is that you can still apply Strauss theorem to establish that between F and H there is a martingale, a joint distribution that is a martingale. However, you can also construct one such martingale so that it satisfies the previous monotonicity condition. In other words, if you look just at the marginal distribution of actions, there is no further restriction besides the fact there has to be a contraction of the prior. And this is relevant at least for two reasons. First, again, if we look just at distribution of ratings, then that is not enough to establish whether or not there was soft information. And for a more practical point of view, this is a result that is going to be helpful for us to actually solve, in some cases, the model. So this is what we can do. I had prepared another slide about implementation that actually concerns the question that Xiao was asking about monotone partitions. Not only you were right by saying that if we impose deterministic mechanism, then what you get is monotone partitions. But actually, in the present setting, monotone partitions are also all and only all the credible mechanism. So again, when you have deterministic, you have at the same time truth-telling constraint and credibility in the sense that you have defined in your paper. But again, this was just a digression. Let me keep going on the analysis. Now, I have told you what is implementable. Let's think about the three problems that I have described to you. For the first case, the monopolistic case, solving the problem, or at least simplifying the problem, is pretty simple. We can just replace the transfers with respect to the virtual surplus by just using the usual envelope condition, envelope formula on transfers, which says that rather than maximizing the total surplus, the monopolist should maximize the virtual surplus, which is obtained by taking the original payoff of the sender, which is theta times A plus B, and removing the so-called information rents. The information rents are the inverse Zarza rate of the prior times the marginal utility of the sender, which is equal to A. With this, the overall problem of the monopolist becomes that of selecting an outcome that satisfies consistency, obedience, and monotonicity, so to maximize J. In the sender preferred case, you can apply the same steps to show that what the problem that you're solving is the same, with the difference that you actually maximize the original payoff of the sender as opposed to the virtual surplus. And again, I want to stress that the difference between these two programs and standard, let's say, Bayesian persuasion is exactly this monotonicity constraint. What about the restricted case? I have no time to cover it in detail. I just want to stress that in the case in which the transfers cannot be negative for any type, given the fact that these transfers must be non-decreasing, it is sufficient to check that the transfers paid by the lowest type is weakly positive, and the envelope formula again gives you that this transfer has to be equal to the conditional expectation of the state-independent part of the payoff of the sender at 0. This means that when the non-negative constraint is added to the sender-preferred case, the problem of selecting the sender-preferred mediation, the sender-preferred mechanism, becomes the one of selecting an implementable outcome that again satisfies consistency, obedience, and monotonicity. But now what is the objective function is equal to the information rents. So observe that while here we are removing the information rents from the payoff of the sender, here those are the objectives, the direct objectives that the sender preferred outcome is considering, plus this payoff that is obtained by bunching some types at 0. And this slide should already tell you that in the restricted sender preferred case, there is an intrinsic incentive for the sender to actually release less information. And the reason, again, it's because the transfers to the mediator must be weakly positive. Given that the transfers must be weakly positive, the sender will have an incentive to commit to a mechanism that does not sacrifice too much transfers to the mediator, but at the same time that cannot disclose as much information as the case in which the monopolist is maximizing the amount of transfers in the economy. And again, you see this by the presence of this payoff that depends on the bunch at 0, meaning that if there is a bunch of types at 0, then the overall payoff of the sender is going to increase. Now, these are the three programs simplified given our objectives. We can, in principle, think of this problem as a problem of selecting directly the joint distribution of states and action, so to maximize these three objectives, right? Under the two constraints. One is obedience, and the other is monotonicity. Now, if the payoff that we are going to maximize is strictly supermodular and convex, meaning that the designer prefers to have an assortative matching between states and conditional expectation, then more information should be revealed in equilibrium. And that's actually the condition that we are going to use to show sufficient conditions such that full disclosure is actually optimal in the case of monopolistic mediation. To be more formal, if the virtual surplus is both supermodular and convex, meaning that the virtual surplus prefers spreads of the conditional expectation and assortative matching between states and the conditional expectation, then full disclosure is optimal under monopolistic competition. If the original payoff of the sender was supermodular and convex, that's also the case for the unrestricted sender preferred case. However, as we're going to see, full disclosure can never be optimal for the restricted sender preferred case, exactly because of the presence of the bunch at 0 that must be satisfied when transfers cannot be negative. So in other words, this result is saying that under this condition of supermodularity and convexity of the virtual surplus, there is always going to be more information revealed in the monopolistic regime, and that's because full information is actually revealed in a monopolistic regime, as opposed to the case of sender preferred outcome with a restriction on transfers. Okay, let me actually skip the sketch to give you more concrete results on other cases that are not full disclosure. And in order to give you this result, I'm going to make an additional assumption. I'm going to assume that the states are uniformly distributed. Some of the results I'm going to show to you can be generalized to the case in which the state is not uniform, but still is regular according to Myerson. But I think that the derivation with uniform states is more transparent. So again, the key condition that I'm going to assume now is regularity alla Myerson, which means decreasing inverse as a rate. For simplicity, let me directly focus on the uniform case. Indeed, when theta is uniform, the virtual type of descender, as we all know, is just this linear function of the state. Now, remember what is the payoff of each receiver with outside option R when the state is theta. The payoff is just equal to A, their binary action, times the difference between the state and the outside option. Suppose that you fix a distribution of conditional expectation H, then you can actually write down the expected payoff of receiver R. What is the expected payoff? Well, the expected payoff is the expectation of the conditional expectation every time that the realized conditional expectation is weakly higher than their outside option. Why? Because those are the times in which the receiver is going to play action 1. And in particular, this function, which depends on the marginal distribution over conditional expectation, is convex and must always lie between the corresponding utility for receiver R under full disclosure and the corresponding utility of receiver R under no disclosure. And actually, this set not only gives you necessary conditions, but also sufficient, meaning that all the profile of utilities for receivers that can be induced under a mechanism are exactly those that induce a convex function UR that is bounded. Sorry, here there is a typo. This should be weakly lower than UFD. So a convex function that is bounded from above by the utility under non-disclosure and from below by the utility of non-disclosure and from above by the utility of full disclosure. So again, given that all the marginal distributions that are mean-preserving spread can be implemented that are mean-preserving contraction can be implemented with one such mechanism, then we know that all the profile of utilities of the receivers that are convex and lie between these two functions can be implemented by the mediator. Now, we have established what utility for the receivers can be implemented. What about the payoff of the mediator and the sender expressed as a function of the profile of a receiver's utility? It turns out that you can actually write both these expected payoff, the expected revenue of the mediator and the ex-ante payoff of the sender as a function of the profile of utilities of the receiver chosen. And in particular, these always are going to be linear functions of the profile of utilities for the receiver weighted by a weighting function. And I claim that the only difference between the three cases, so the monopolistic case, the sender-preferred case, and the restricted sender-preferred case, lies in the difference between the weighting function with which they are going to distort the utility of the receiver. So just to summarize, this slide shows you that in all three cases, you can solve the problem by directly selecting the profile of the utilities of the receivers with a distortion. And these three distortions, psi m, psi s, and psi greater or equal, exactly correspond to the distortions in the three cases: monopoly, sender's preferred case, and restricted sender preferred case. So every time that this distortion is going to imply that the mediator wants to decrease the utility of the receiver, so when this distortion is negative, then the receiver is not going to be better off, exactly because it's in the interest of the mediator to decrease the payoff of that particular receiver. And you can immediately observe that the relevant competitive case, the one in which we restrict transfers to be non-negative, already has a negative term. And in particular, if this alpha function is a constant function, meaning that this term is 0, then it turns out that the weighting function is always negative, implying that under sender-preferred selection, the mediator is going to select no disclosure and minimize the utility of the receiver. At the same time, when this function alpha prime is equal to 0, so alpha is a constant and beta is also a constant, so that this beta prime is equal to 0, we see that the distortion of the monopolistic mediator is always positive. So when alpha and beta are constant function, a standard case, I would say, the monopolist actually maximizes the payoff of the receiver, whereas the sender preferred case under restriction is going to minimize the utility of the receiver. So in a certain sense, perhaps surprisingly, the monopolist is going to do what is in the best interest of the receiver, whereas a perfectly competitive market is going to do what is in the worst interest possible for the receivers. I try to convey to you the intuition of the results that I'm going to show you. Now, there are formal results, depending on the assumptions that these three weighting functions have, that show that the monopolist will always actually disclose more information than the restricted sender preferred case. And in particular, as I was claiming just a moment ago, full disclosure is never optimal for the restricted sender preferred case. And actually, in most cases, no disclosure is optimal for the restricted sender preferred case. And this happens if and only if the elasticity of this alpha function, the state-dependent payoff function of the sender, is less or equal than this expression of R. A sufficient condition for this expression is that the utility of the sender that depends on type is actually weakly decreasing. So if alpha is a weakly decreasing function, then in a regime of perfect competition among mediators, with the restrictions that the transfers need to be weakly positive, no disclosure is the only equilibrium outcome. What about instead the comparison between monopolistic case? Yes.
It's 5 o'clock now.
I have one slide, one last slide. Okay. This is the last slide. What about the comparison between mediation and sender preferred case in the non-restricted case? And remember, this non-restricted case actually would correspond also to Bayesian persuasion. So this slide, in a certain sense, also tells you what is the comparison between a regime of monopolistic mediation and a regime of Bayesian persuasion where the sender has a commitment to begin with. Suppose that this condition is satisfied, so for example, alpha is a decreasing function, then there exists a distribution of receivers that it's dominated by the uniform distribution according to the first order stochastic dominance order, such that the solution of the monopolist is greater or equal, so the expected utility of the receivers according to the solution of the monopolist is greater or equal than the expected utility of the receivers according to the solution in the sender preferred case, and according to this weighting function. In other words, there exists a welfare aggregation function of all the receivers such that the solution of the monopolist makes the receivers according to this welfare function better off than both the sender preferred case, this time restricted, or equivalently Bayesian persuasion. So again, this should tell you that in most cases, the monopolist will make better off, at least on average, the receivers. Let me jump to the conclusion. Again, we analyzed a model, one-dimensional screening model, in which a mediator faces both obedience constraint and truth-telling constraint, and we claimed that, in this model we compared monopolistic mediation with the case of perfect competition, both restricted and unrestricted case in terms of transfers. And we have seen that in several regular cases, for example, when the state is uniformly distributed, but more in general when the regularity according to Meyerson is satisfied, the solution of the monopolist induces a weakly higher and often strictly higher payoff for the receivers. Again, suggesting that perhaps sometimes a monopolistic regime in these markets for rating agency might be even favorable and preferred from the point of view of market participants. And the two reasons for these results are the fact that there are distortions coming from information rents and the fact that the transfers from the sender to the mediator exactly act like money burning in the standard chip talk. So let me stop here. I'm already 3 minutes beyond my time schedule and take questions if there are any.
Yes, so we're going to start with a panelist, Xiao, Roland, whichever wants to start is welcome to begin.
I can start. I'm wondering if you, so have you considered comparing the sender's payoff in the monopoly intermediate problem with a problem where the intermediary can only charge a uniform fee? Because this report contingent transfer is doing two things, right? One is allow more tools from the intermediate to appropriate surplus. But at the same time, it enlarge the pie by allowing a larger set of implementable outcomes. So it's unclear whether they will help the sender or not.
Good. Okay, two things. Depending, what is your goal here? If your goal is to actually help the receivers, which are the market participants, the investors that are going to use, this result is saying that as a regulator, maybe you should allow for transfers that can depend on report. Why? Because even in a monopolistic case, that would allow, as you said, would increase the amount of implementable outcomes and increase the amount of information that can be revealed.
Yeah, but if we care about issuer, sorry.
Can I jump? I thought you had a revelation principle, so I'm not understanding the revelation principle now anymore, or your result. If you say you can do even better with.
No, he was saying, but he was comparing that to a model that is different from a model in which transfers cannot depend on the.
It must be a uniform price. Like
must be a uniform price.
Okay.
In this model, the implementable outcomes are much less restricted than the implementable outcomes in my model, and therefore not a lot of information can be communicated, either in the monopolistic case or in the perfectly competitive case.
Yeah, so certainly it's worse for the receiver. So that's why.
Sorry?
Certainly, for the receiver side, I think the comparison is clear, but for the sender side, I don't have a clear intuition. Does it improve or hurt the sender?
No, I think it also, like, of course, a formal statement should, like, depends on the payoff of the sender. But suppose that you are in the case in which the payoff of the sender is strictly supermodular and convex. So you are in this case here, which I think it's weak enough. Suppose that it's both V and J are supermodular and convex. Then the sender would also like to have full information, because that's the solution of the Bayesian persuasion problem. Now, if you don't allow the monopolist to have report-dependent transfers, you cannot do full disclosure. Full disclosure is not anymore implementable, exactly because you have removed the variation of the payoff as a function of.
But I saw the intermediary is appropriating less amount of surplus, right? In that case, because
but also the sender,
Okay, so
because actually I claim that if this payoff is supermodular and convex in X, and remember, under my assumption, this payoff is always strictly increasing in X. I actually think that in your model with flat fees, only no disclosure can be implemented without transfers. Because the payoff of the sender is strictly increasing in X. It is strictly increasing in X, which means that if you have in equilibrium two different conditional expectations, then the truth-telling constraint cannot be.
There's no mixing. Yeah, it's not like in your other paper where you can.
Yes,
yeah,
exactly.
I see. Yeah,
exactly.
Yes.
So I was thinking about welfare results. So my understanding is that the sender, of course, is better off with the competition.
Yes.
Yeah, and you have conditions where the receiver actually dislikes the competition, right?
Yes.
So what about, so there's a trade-off. So what about overall welfare? Do you have results on that?
Not here. Having said that, if by welfare you consider a convex linear combination of the payoff of the receiver and the sender, you can just put it into this J. You can define a new J that depends on a convex linear combination. You can also actually include transfers, right? You can have a convex linear combination that will have the payoff of the sender, the payoff of the receiver, and transfers. So the the three agents in the economy, and you can try to derive conditions such that for a given set of weights for these three payoffs, one, the monopolistic case or the perfect competitive case is better off. However, I have not analyzed in detail that problem, so I don't know exactly what conditions. Of course, an easy answer that I can tell you is whenever the weight on the receivers is large enough, then my result is going to apply by continuity, and therefore in that case you would have that.
But you have a quasi-linear setting, so the transfer wash out if we also take into consider the
no,
mediator.
But the receivers do not have transfers. Remember that the receivers,
right.
There is no transferable utility between the receiver and the mediator. There is transferable utility between the mediator and the sender.
I see. Okay, I see.
But it's a fair question. It's I should actually have at least a couple of results on general welfare. I think it's a natural.
Yeah, because well, it has high policy relevance, right? These are questions that the credit rating agencies, what they are allowed to do, what kind of mechanism they're allowed to use. That's one of very potential, important questions. So if we had some, ideas what soft information is doing.
No, right, but exactly from a regulator point of view, I was thinking to a regulator that mostly cares about informativeness and the payoff of the the investors. But yes, we should think to.
Well, I don't know. So the informativeness is only a means to get to maximum welfare, right? So often they go in the same direction, but not always. So so information is not per se the goal, right? That's why I was pushing for the welfare effects.
But I think it's a fair question. I think that I should consider at least one case in which I have an average of all the three of the welfares of all the three agents.
And there is no role for transfers from the receivers do they want to subsidize somehow even if they could actually subsidize the sender, so bypass the mediator?
Okay, of course there is an alternative model in which the receiver, suppose that there is only one receiver, that the receiver has commitment power, then they would behave as a mechanism designer because they also have control of the final action. So basically it becomes an allocation problem with incomplete information and transfers. So yes, that case would basically would be a standard screening problem.
Then you could replace the mediator by one of this.
Yes.
Okay.
I don't know whether that case, I don't know what are the welfare comparison between this case in which the receivers act as a mechanism designer with respect to the case in which there is a mediator. But again, for the settings that I have in mind, it's not exactly realistic to have receivers or like financial institutions. I mean, I guess in some cases there are institutional investors that can propose a menu to issuers, but I see that as a little bit counterfactual with respect to what we see in this market.
Well, you also see often regulation that says that, well, maybe that's not the case here. Yeah. So how transparent actually the payments are, because here you cannot see the payment, right? That actually being sent, right?
Right.
And that I don't, there's some regulation pushing also that to be transparent, in order to fight collusion issues between the mediator together with the sender. That's also why issuers paid credit rating agencies are very much criticized, that it creates these collusion and stuff. But that's not part of your model, right?
No.
That would undermine the full commitment of the I see.
Okay. I think we could stop the recording now, even though it's still 2 minutes left, because as I said, Roberto, if anybody has a very quick question, maybe just unmute yourselves.
I have a sort of more speculative question if there's no one else. So just about thinking a different framework in which you have senders, some kind of advertisers, mediator is a newspaper, and receivers are a public. Would that fit? Because I'm trying to think through certainly some of the aspects, and it seems to me that the framework you have is sort of more general and can fit not only the credit rating agency, even if you call it those mediators like that. In fact, last week we had a presentation, by Heskey, sort of fitting some similar scenario.
Yes, I guess this paper suffers still of the bias due to job market, in which it's better to focus on one application, I guess. Sometimes
okay.
claiming too many applications, it's counterproductive actually, because then people don't know what you're talking about exactly. So
no, but we have our own applications in mind. So
I think
will the machinery fit?
I think you're right. I don't know whether newspapers, maybe more than newspapers, like a more modern take would be browsers or online platforms. But
yeah, Twitter.
I think that would also be yes. And indeed, actually in the paper I talk about that in the presentations. I wanted to focus on only one application, but yes, definitely more than newspapers, I would say. Yes, a centralized like a browser or a platform, an online platform. But yes, I think you're right.
Thank you.
Okay. Anybody else? I think I have to go. This is part of the problem. I'm chairing this and I have to go. Roberto, I actually did have a question, but I think I might just email you a little bit later. I just wanted to thank Xiao and Roland for coming and helping us. Thank you, Roberto, of course, for doing
Thanks
this
for inviting.
really interesting presentation. Thank you, everyone, for attending. Again, we're going to stop now for the rest of December, probably start again at the end of February, early March. Any news will be on our website, so we'll also advertise through Blue Sky and Twitter and so on. So you should get the information soon about what we're doing next.